Alright, ladies and gentlemen, this is a nuclear decay lesson. Nuclear decay. Nuclear decay is when the nucleus of the atom breaks down over time. Okay, it will emit different particles. And we mentioned a couple of particles already. And the first particle is, let me go make here real quick. The alpha particle. Alpha particle, which is a helium atom. It's got a atomic number 2 protons, and the mass is 4, or sometimes it's written as the alpha sign, just kind of like alpha, like that, like an A, 4 and 2. So that's your alpha particle. And then your beta, it is written as an electron with a -1 charge here. -1 means it has one more electron and no proton, and the mass is 0. Or it's written as the beta sign, beta, like that, 1 0, same thing. Okay, and then you have a positron. Positron is an electron with a positive charge. This one, E with a positive charge, or it's a positive beta, which is +1 and 0. So these symbols are interchangeable. You see one of these, you just know that, hey, it's positron. Be able to identify beta, alpha, and then gamma. Let me clear this up. I can say right here, gamma. Gamma it's got no charge. It's like a letter Y, and it has no charge. So gamma, and we have another one, which is a neutron. Neutron is just neutron here with no proton. It just has a mass of 1. Oh no, that's at the corner. I want to move that up here. You have neutron here. Neutron, which N here. It's got a mass of 1 and it has no charge there. No proton. And then you have a proton, which is, sometimes you see a proton is written as hydrogen, atomic number 1, and has a mass of 1. Or it could be a P with the H. So these are the different symbols here. Okay, the most common ones that we'll see is alpha, beta, and gamma. Remember, alpha is sometimes written like this with the A. It's actually better when it's an A because you think you know it's alpha. With the B, you know it's beta. It's more obvious. Okay, but identify that E with the -1 at the bottom and a 0 mass on top is your beta as well. So you look at number 1 here on your worksheet. 42. So balancing nuclear equation is fairly simple. You basically need to add the top numbers have to be equal and the bottom numbers have to be equal. Okay. So understanding that here is potassium. You need to find the atomic number to write at the bottom. Okay. So on your periodic table, find the the atomic number of potassium. The atomic number for potassium is 19. So 19 goes here. Alright. So now, this side is -1. -1 plus what gives you 19? So the right side and the left side has to balance out. Okay. So you put 18 at the bottom, and 18 will give you the atomic number. So find the element number 18. So it's argon, so you write AR. And the mass number on top. Now, right, 8, okay, take a step back. So these numbers here, 19 is, no, I'm sorry, I messed up. -1 plus what gives you 19? -1 plus 20, actually, not 18. Sorry, I'm a little slow here. So argon is there. Not argon, 20 is not argon anymore. 20 is calcium. Messing up a lot. Again, you can mess up and learn from it, right? So calcium there, calcium 20. And so look at 40 is 0 plus what? So the same thing here, 40. So the right side has 40 plus 0 is 40. Not 40, what am I doing? It's 42. 42. Get it right, Day. 42 plus 0 is 42. They have the same. Okay? So the top adds up to the same number. The bottom, both sides equal each other. And that's how you balance the equation there. So what kind of decay is this? You see the E here, E -1, that is your beta. This is the beta decay. Okay, it's a beta decay. Number 2, let's find Pu. Pu is what atomic number? It is all the way, where is Pu? Mass 239. Pu, number 94. Wow. Number 94. Okay, a lot of these nuclear radioactive elements, it's going to be the bottom 2 rows. A lot of them are down there. Okay, so split this up, the left side and the right side. So we have 2 on the right side, right? 2 plus what gives you 94? So 94 minus 2 will give you 92. Okay, and then the top, look, 239 minus 4 here is 235. Okay, but which number helps you find the element? This 92 here, that's the atomic number. At the bottom is atomic number, the top is the mass number. Atomic number 92 is uranium, so it's U like that. Okay, so that's how you balance an equation. So practice. What kind of decay do we have here? Keep identifying these things. Helium 2 plus. Helium plus 2 is an alpha particle, so this is an alpha decay. D-E-C-A-Y, decay, yeah. And yeah, so it's pretty straightforward. Guys, look at the sides, both sides, left and right side. The left side's here, right side's here. Oh, sorry, the right side's everything on the right of the arrow. Add up the numbers on top, need to be equal. The numbers at the bottom need to be equal, and then you have a balanced equation. So number 3 here, look at that. 231 plus what on this side gives you uranium? So it's 4. 231 plus 4. These two numbers add up to be that number right there. Okay. So 90 plus what? 90 plus 2 will give you these two numbers down here, add together to get you that number. Okay. So 90 plus 2, 4 and 2, that's your alpha particle or your helium. You put alpha or helium, which is the same thing. Okay, so there is your particle, that's that. That's another alpha decay. Okay? Pretty straightforward. Let me go down here. Just cover that sucker. So if you have 3 things, like number, let's look at number 9. That's the most it looks complicated. So you need to add up all the numbers over here. Add up all the top numbers. 142 plus 91 plus 1. Oh, there's 3 of those. This one is tricky. So it's 3 of these. So then this one you actually have, and there's 3 of them and 0 right there. There's 3. You multiply it by 3. So you add up these numbers. 142 plus 91 plus 3. I get what? 6, and then 9 plus 4 is 3, 1, 236. Right? So I have 236 on top over here. So so these two numbers over here, top number and whatever the numbers up here, needs to add up to 236. So 236 is 235 plus 1, that gives you 236 on this side. Okay? So the whole point is get all the top numbers to be equal on the left and the right side, and now get all the bottom numbers to be equal. So the bottom numbers, I have 56 plus 36 here. And I have 0, so that 0 doesn't do anything, so that's 92. You add these two numbers, that's 92. So the bottom number over here needs to be 92. You see 92 plus 0 is 92. So that size 92, this size 92, check, check. Okay. So element 92 is very common, uranium. Element number 92, the 4th element at the very bottom of the page, that's 92. That is how you do these equations. Fairly simple. It's basic addition and subtraction. Use a calculator if you need. And sometimes mental math makes you mess up. Okay. That's number 9. Go back to number 6 here. Look, there's 3 things. So there's 3 things here. The middle, the arrow tells you balance everything on the left, balancing everything on the right. So if I add the top here, 27 plus 4, I would have 31. Let me write on top. So this has 31 on top. What's on the bottom? 15 is on the bottom. 13 plus 2. So this side, 15 is on the bottom already, so this other particle will have 0, because 15, this needs to add to 15. So on top here, it needs to be 31, so the top number here needs to be 1 to add up to 31. See that? Let me erase all these arrows so you can see there. The top is 1. So 0 and 1, what particle did we have earlier? That 0 has 0 and 1. What particle was it? That is just a neutron. Okay, that is just a neutron. Has 0 charge and basically 0 atomic number, no proton, and it has 1 mass because it is just a neutron. Remember, neutron is the same as proton, same mass, almost the same mass. So neutrons 1, protons 1, electrons 0, no mass. Okay, so that's how you do that. So go ahead and finish these questions, number 7, number 8, number 10, and as well as the ones above that I didn't do. So we'll come back, we'll check this, and to make sure you got it down. Thank you very much.